Chemical equations. Chemical equations are a sort of a shorthand representation for a chemical reaction. They describe a chemical reaction. And we have different types of equations. The substances on the left side of the arrow are called the reactants, and the substances on the right are the products. So here we have an example. It's a little bit like a math equation, in that it is, the things on both sides are related to each other. The arrow stands in for the equal sign. The arrow indicates direction, whereas an equal sign does not indicate direction. But the things over here on the left, we go left to right, the arrow points left to right, just like we read left to right. So these are the things that we're starting with. These are called the reactants. The reactants react to produce the products. So we start here with the reactants and we produce these products. It's important to get those straight. We often indicate the physical state of the reactants and products after their chemical formulas by using what we call state symbols. So in parentheses there'll be a letter. G means that these are all in the gas state. Sometimes it's important to have the states indicated and other times it isn't. But these are the states and we need to know what they mean. G for gas, L for liquid, S for solid, and AQ stands for aqueous. It's a little bit like the Spanish word agua, meaning water. So aqueous means that it is dissolved in water. It's a solution with water. If we look at this equation here, this chemical equation, we have one methane molecule and one oxygen molecule. And here we have space-filling models of them. So the carbon is the black ball in the middle and it's got 4 white balls attached to it, that's the hydrogens. And oxygen is red in this picture and it's got 2 oxygen atoms because it's O2. And so I think of atoms as being a lot like Lego bricks. And so you could imagine if these are just funky round Legos, that you could take this guy apart and you could take this guy apart and you can put them back together in different ways, right? Could you take these 2 things apart and make those 2 things? Over here we have, to make both of these, we would need 3 red balls, right? And there's only 2 red balls on that side. Could we make both of these out of these starting pieces? No, we can't. Well, we learned about conservation of matter. Matter must be conserved. Atoms cannot simply appear or disappear. Just like when you're playing with Legos in the living room, and my kids, we've been collecting Legos for about 20 years, so we have quite an impressive Lego collection. Playing with Legos in the living room, Legos do not just appear out of nowhere. It sometimes appears that way, seems that way, where did all these Legos come from, but they actually came from somewhere. And they don't just disappear. They get under the couch and under the rug, and you step on them and stuff, but they don't disappear, and atoms can't disappear either. Over here we've got 4 white balls, and over here we only have 2. Does that mean that 2 of those white balls just disappeared? No, it means that our equation is wrong. Our equation here is not showing us what's really going on. So we need to adjust the chemical equation. So kind of already talked about that, but what we need to do is we need to create a balanced chemical equation. So if we had 2 of these oxygen molecules and 1 of the methane molecules, let's draw on here because we can. Let's do purple, I don't know. So we could take this black ball, and that's going to be this guy, and these 2 guys could go over there, right? So we've got this guy taken care of and that guy and this guy in the middle. And then over here we need 4 white ones. So 1, 2, 3, 4, those guys are accounted for. And we need 2 more of the red ones. And so there's those guys right there. So we could take these three starting molecules, take them apart, put them back together, and end up with these. You see that? That's what a chemical equation is doing. It's just describing how many of each of these things are we starting with. The formulas in the chemical equation tell us what pieces are in this structure. This coefficient, this number in front, tells us how many of those groups we have. So O2 tells us each of these is two O's stuck together. The 2 in front of it says we have 2 of those groups. CH4, there's a carbon and 4 hydrogens. When we recombine those, we're going to end up with 1 CO2 and 2 water molecules. Each water molecule is 1 oxygen and 2 hydrogens. Yes, question?
That's most likely a combustion process, right?
That is a combustion reaction, yep. Reaction of methane with oxygen.